Okay, we'll start with this problem, number of equivalent domino pairs. Given a list of dominoes I equals to a comma b is equal to dominoes j equals to c comma d if and only if either a equals to c and b equals to d, or a equals to d and b equals to c. Two pairs have to be equal. That is, one domino can be rotated to be equal to the other domino. Return the number of pairs ij for which 0 is less than equals to I is less than j less than equals to dominoes dot length, and dominoes of I is equivalent to dominoes of j. One, two, two, 1, 3, 4, 5, 6. 1, 2 and 2, 1 are domino pairs. They have to be equal. The elements have to be equal. Okay, here 1, 2, 1, 2, 1, 2. 3 3c2 is n minus 1 by 2. So equivalent domino pairs. Okay, how do we do it? Let's do this. Let's say we try to use a hash map. We'll go through each pair of dominoes, each what do you call, each element, each entry. Okay, so for each entry in dominoes you have to create a key out of it, right? Some key to generate, to distinguish each. So what I'll do, it is a smaller plus some signal and then a higher value. So I need to get a smaller value first. So a equals to entry of 0 and b equals to entry of 1, and if a is less than b, then it's good, but if in case a is greater than b, I'll swap them. So I'll do int temp equals to b equals to so b is saved now, so a equals to b equals to a and a equals to temp. That is how I swap it. And now I do key. So key are giving us a string. Yeah, so key a plus, let's say this plus b. So this will be unique. And now I'll do it, this is, let's do a var. So for this is the key. Now map dot put 1 plus map dot get or default key comma 0. So this is what it is, and now I go through each and every. I can also do this if it exists. I don't even have to go through the map entry again. I can do it here itself, which is this. So for example, there are 4 and 4c2 is 6. And the reason for that 4c2 is 6 is because when it's 1 there's nothing, when it's 2 you have 1, right? So 2c2 is not 1, 2c2 is 1. Okay, so for 2 you get 1, for 3 you will add 2 more, right? So 2, 1 plus 2, 3. For 4 you will add 3 more. So yeah, you're getting it. So what you're going to do is So we're done with problem number 1. Now we'll move to problem number 2. So you go to problems, let's get rid of that. Let's put on some filters. Status is to do. Let's take the difficulty as easy only for now, and pick a random problem. Alrighty, binary gap. This is our problem number 2. Given a positive integer n, find and return the longest distance between any two adjacent ones in the binary representation of n. If there are no adjacent ones, return 0. Two ones are adjacent if there are only zeros separating them, possibly no zeros. The distance between two ones is the absolute difference between their bit positions. For example, the two ones in 1001 have distance of 0, or have a distance of 3. Okay, let's understand it. N equals to 22. 22 in binary is whatever it is. The first adjacent pair of ones is 10110 with a distance of 2. Okay, this is 1. The second adjacent pair of ones is 1 with a distance of 1, and the answer is the largest of these two distances, which is 2. Note that 10110, this one and this one is not a valid pair since there is a 1 separating the two ones underlined. Okay, so distance between two consecutive or adjacent ones is what we have to find. We have to find the longest distance. Okay, 8 is this. There is no two pairs of ones, so the answer is 0. Okay, 5 is 101, so the distance is 2. Alright, let's see the problem again just to be so that we are very sure. Given a positive integer n, return the longest distance between any two adjacent ones in the binary representation of n. If there are no two adjacent ones, return 0. I think we got it. In 1001, it's 1, 2, 3, distance of 3. Okay, so now the question would be, can I convert it into a, let's say I convert it into a string array or a integer array or some array of size whatever, which is only ones and zeros, and so I can create what I like a linked list of ones and linked list of zeros. and I have to find the adjacent. So I mean, if you can go through it, and from A you go B, what is the difference, what is the difference, what is the difference, like that you can do. Okay, so I just need a binary representation. If I can get the binary representation, it's an easy problem to solve. Now how do you get a binary representation of a number is in a string or an array form? It probably just dilutes down to that. I hope it's a positive number. It is a positive number, so can create an array or something, do you think? I mean, yeah, divide by 2 percentile 2, you'll get 0 or 1 or something like that, or right shift or whatever, right? You can get the rightmost is it, and consider that as index 0 if you wanted to. So okay, then it means it's a 1, and if it means it's a 1, and then you're gonna do this. Current index will increase, and another thing that will happen is you remove the last one, okay, or whatever last is it. So and one, if the last digit is indeed 1, then you wanna look at the last one. Then you do last one equals to current, and if that's not the case, then you find another one, then you do and then you would also want to do last one equals to current, right? So if last one is not equal to -1, then you would do this, right? And then you would obviously you would say this last one is this as well, and whether it's 0 or not, you would do this. Yeah, I think that's it. This is pretty much it. It's a simple problem. You would return the result. Let's run the code. N equals to n. Is it like this? Does this work? Oh, you got the wrong answer the very first time. Okay, so let's see what the problem is. N equals to 8, we got the right answer because there was no pair, but for everything else you got wrong. So 22 you're getting 0, Are you always getting 0 by any chance? Yeah, you're always getting 0. Okay. Does that mean that you never get inside this? Let's see if we ever get inside this. We do. So for 22 there are multiple ones, but I get inside there's only one time, and at what index do you get, right? Let's see that as well. So for 22 you get it at index 4, which is 0 1 2 3 4. Okay, I mean this is actually not right. Yes, you would want what? I would want like a fox 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 fox, something like that, right? Or you can do this is equal to 1. That is also fair. Let's try that again. It was a mistake. Alright, working now. Fixed the bug. Submit. We're done with 2 problems. Let's move on to problem number 3. Okay, we'll move on to another problem which is free. What is this? JavaScript we don't do. Alright, this is our problem number 3. Minimum value to get positive step-by-step sum. Given an array of integers nums, you start with an initial positive value start value. In each iteration, you calculate the step-by-step sum of start value plus elements in nums. Return the minimum possible value of start value such that the step-by-step sum is never less than 1. We are given an array of integers. You start with some positive value start value. In each iteration, you calculate the step-by-step sum of start value plus elements left from left. Return the minimum positive value of start value so that a step-by-step sum is never less than 1. Let's understand. So if you choose the start value as 4 in the third iteration, okay, why when I say 4 is this, or 4 is some any random value? Because you have to be given a start value, no? Or you have to choose a minimum positive stop value so that the step-by-step sum is never less than 1. Well, that just means you sum all of them, and or you do a cumulative sum, and at any point if the cumulative sum is basically, is it the answer 4? The answer is 5. Okay, if you choose a start value as 4 in the third iteration, your step-by-step sum is less than 1. I mean, just look at this. You just have to have a cumulative sum, right? So for this example, the cumulative sum is -3. Then the cumulative sum is -3 plus 2 is what? -1. Then -1 minus 3 is -4. Then -4 plus 4 is 0. And then 0 plus 2 is 2, right? So the smallest value is this of cumulative sum is -4, and you would want it to be 1. Then you would, what you would you start with? 5 minus 4, right? So it's as simple as that. So you find the smallest possible cumulative sum value, and then how much you need to make it 1. It's as simple as that, no? So nums of 0, hopefully the number of elements are, is it smallest positive or minimum positive value? Okay, we'll figure that out. I'm hoping there's at least one element. Yeah. So a plus b equals to 1, start value plus x equals to 1, so start value equals to 1 minus x. Okay, let's run. I'm gonna get a compilation error. Let's fix it. Error interface class number got something which I don't fully get. Line number 20. Okay, that we can fix easily. Run, and it works as well. This is our problem number 3. Okay. Now we'll go ahead with problem number 4. This is our problem number 4. Sum of root to leaf binary numbers. Okay, let's understand it. You are given the root of a binary tree where each node has a value 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. For example, if the path is 0 to 1 to 1 to 0 to 1, this could represent 0 1 1 0 1 in binary, which is 13. For all leaves in the binary tree, consider the numbers represented by the path from root to that leaf. Okay, so for every leaf, you have to find the path from root to leaf. Return the sum of these numbers. The test cases are generated so that the answer fits a 32-bit integer. Okay, let's look at the problem. So 100, 101, 110, and 111. Right. So you have to do like a traversal from root to the leaf. Root, left child, and then right child. Do like a pre-order traversal, I guess. Okay. So, and when I'm doing a pre-order traversal, can we write a pre-order traversal of this? Okay, the pre-order traversal of this will be 100, 101, 110, and 111. That is the pre-order traversal. So pre-order traversal makes the most sense to me. So I go pre-order traversal. And another thing in pre-order traversal is you're gonna have to do backtracking as well, or not, I don't know. When I get to the leaf, I have to add. When I get to the leaf, I have to get the entire number, and add it somewhere, right? Okay, I mean, I can always maintain like a global thing. Let's maintain like a global thing. So int sum starts with 0, and then you do return sum. And what I was thinking was, can I make this sum as here? Like, can I do here? Is what I was wondering. Is that possible? So every time you create a method solution, whenever this function is called, you can always make it 0, initialize it back, in case if you're using the same object but calling it multiple times with different root values. Can do that. We'll start with this simple thing. Okay, so so that I don't have to pass the sum now because it's global, so I don't need to pass it, but I need to pass something which is some path. Let's just call it pre-order traversal. Yeah, who cares? Let's call it, I'm traversing it in a pre-order fashion, and I'm gonna call root, and I'm gonna also call the current value. Okay, and am I returning something? Okay, let's figure that out. So I give this to you, and then when I go to I mean, can I say I will do this? Let's try. Figure it out. I'm still not sure. Okay. Because what? Because something. We'll see. Let's see. So int pre-order 3 node root int sum, I guess. So now what do you do? Okay, this is what I do. So if root equals to null, you return sum, right? Otherwise, if root is not equal to null, then you would add this, right? So you would do sum equals to sum left shift by 1, and you would add this whatever the value of is. It's either 1 or 0, right? So if it's 0, you don't add anything. If it's 1, you add 1. That's perfect thing. This is sum that I have considered with root, and then I'll go sum equals to pre-order root dot left sum, and right sum equals to pre-order root dot right sum. So I get So I get 110 and I get 1.1, for example, and then I'll do I guess this is fair. So you remove this, just do a pre-order traversal and keep track of the sums. Is that it? Let's run. We are solving problem number 4. Let's see if the test case is passed for one, failed for another. Second one was 0, so it was easy. The first one did fail. Okay, it did fail. So this is where everything will go. So we print it, I guess. Because this is when you're actually reach the leaf. Yes. So let's see if that's the case or not. 4, 5, 6 and 7. We're printing what? 4, 4, 5, 5, 6, 6 and 7 and 7. So we do get there, but you get it multiple times. Okay, let's understand this now. Let us understand it, what's happening. So I start with 1, and then I say okay, so pre-order root equals to null. No, it's not. Then I get this sum. So 1 is the sum, and then I go here, and I go here as well. But I even go left sum, so I go here, and then I go here. And when I'm on this leaf, I've added it, and then I call it. Okay, I'm calling it left child, I'm calling it right child, and for both of them is that. So you can't do that. You have to figure out if you're a leaf or not. So you can't do left sum plus right sum. You can do it, but you can't reach here. You have to do it in one step before, or because you have multiplied everything twice, you do pi 2. What if there was a single node? Well, okay, even if it was a single node, for example, you would have gone to the left child, you would have gone to the right child, done it twice, and then return 2, right? So are you saying this? Exactly, that's what I'm saying. Okay, let's submit. Okay, you got some wrong answer because of that. What do you do about that now? Use this test case, I guess, and then run it. Okay, expectation was 5. You return 6. 22101333. Okay, I don't know what's happening, brother, but let's not go ahead with this for now, and let's figure out what you can do. So what I'm saying is, if you're a leaf node, you never go to null. Okay, if you're a leaf node, that means what? If root dot, okay, what I'm saying is, don't even do this. You would have counted your sum, and then if I guess you have to know. Okay, one sec. If it is null, then maybe you don't return sum. Maybe you return 0. I don't know what's happening. I'll do it. I'll keep it simple. Okay. Fuck this. For every node, I will have added this value, and now what I'm doing is this: if root dot left equals to null, and root dot right equals to null, then I will return some. Now if, for example, if you don't have a left child, then you don't go there. If root dot left is not equals to null, then you go what? Then you do this. Okay, now let's see what happens. Get a wrong answer. I even getting wrong answer for the first one now, which is even bad. I got 28 instead of 22. And why is that? Because everything will come from these leaf childs, yes? So it's 4, 5, 6 and 7. 9 plus 6, 15 plus 7, 22. Then why the heck am I getting 28? Alright, finally we figured it out. Finally we have solved it correctly. And this is our problem number 4. Submit. Hopefully this works. Alrighty, let's go to problem number 5. Article views. We don't do SQL and all. Can we get that filter? That's okay. Okay. Minimum operations to exceed a threshold value. We are given a 0 index integer array nums. This is our problem number 5. Okay. Minimum operations to exceed threshold value. You are given a 0 index integer array nums and an integer k. In one operation, you can remove one occurrence of the smallest element of nums. Return the minimum number of operations needed so that all elements of the array are greater than or equal to k. Okay. So k is 10. We want all elements to be greater than or equal to 10. These 3 elements are not, so you would remove these 3 elements, is it? Okay. After one operation, number will become equal to 2, 11, 10, 3. After 2 operations, nums will become equal to 11, 10, 3. After 3 operations, whatever. So how many operations you need so that all your numbers are greater than k? Now obviously you can sort it and you can do it in n log n, but I guess there could be potentially something better than that. But let's first do the array based approach. So if you do arrays dot sort nums, and what you want is greater than or equal to 10. There also you can do like a binary search again, but if you're already sorting, which is n log n, binary search doesn't really help much. So for int I equals to 0 is less than nums dot length I plus plus. So this is one approach for sure, but I don't think if it's the most optimal one, right? It clearly doesn't beat too much of the time complexity. So we'll try and figure out the better approach. So reset it. Okay. You can't apply binary search, it's not sorted. You have to partition the array. So you have to use either a heap or something like that. Basically I have to find the number of elements which are smaller than k in the array. I don't have to sort the entire array. Array could be huge. I just have to find the number of elements which are smaller than k. So how about we try and do the quick partitioning drive sort of an approach. So what would a partitioning algorithm do? I don't fully remember how quicksort is done at this point, but I think it could be solved by something like that. Okay, so you know the pivot is key, and this is what I'll do. All the elements which are I'll go through the array. Oh, I don't even need to solve it. I don't need to sort it. I just have to no pivot, nothing. Okay, whatever I did, just don't sort it. That's it. You don't have to sort it. Okay, so you're saying you can do it in O of n for int I equals to 0 is less than nums dot length I plus plus if nums of I is less than k plus plus and return ops. Is that it? Yeah, exactly. I guess that is a stupid problem then. It's a part one. It's like a part one of a problem, but okay. Yeah, O of n, you do it. No space, no time. I mean O of n time, O of one space, move on. Right, let's go to problem number 6. Count days spent together. Problem number 6. Anybody have any questions? No questions, move on. Count days spent together. Alice and Bob are traveling to Rome for separate business meetings. Okay, people are going to Rome for meetings, huh? Here given four strings: arrive Alice, leave Alice, arrive Bob, leave Bob. Alice will be in the city from the dates arrive Alice to leave Alice inclusive, and while Bob will be in the city from dates arrive Bob to leave Bob. Each will be a 5-character string in the format mm-dd, corresponding to the month and day of the date. Return the total number of days that Alice and Bob are in Rome together. You can assume that all dates in these occur in the same calendar year, which is not a leap year. Know that the number of days per month can be represented as 31, 28, 31, 30, whatever. Okay. Arrive Alice 8:15. Month and date. Okay, month, date. Okay, you just have to figure out how to, parse a string, how to get the number and all of that. So let's copy this thing. Right, copy it, and then put int days in month equals to okay. Is this a way to represent an array? Let's verify. I doubt, but let's verify. Is that compiled? It doesn't. Okay, so you do what? Like this. How about this? Perfect. So this compiles. So now you know the number of days. Alice will arrive and leave, and then Bob will arrive and leave. If I can convert that into the exact day number, that's the best thing, right? That's what we should try and do. Convert all the 4 strings into day number. So you add this function int get absolute day number string event, right? Let's say you're able to solve this Then what you do is, I think you don't need it here, then you probably need it like here or somewhere. Okay, but then you get that. So let's say you do this, and ls start equals to do it for all four. Let's say you get the absolute day number from day number 0 to 364 or something like that, right? And now how many days they are together. So now ls start ls end is a line, bob start bob end is a line. We don't know who comes first, so there are multiple things that can happen. One is this: if bob start, right, then return 0. Similarly, if so, that is one case that ls leaves and then bob comes, and the other way around. Okay, if these two are not the cases, then there has to be an intersection. And it depends upon who. Could very well be the entire days, right? Nobody meets. Nobody meets. One could be Alice here, Alice and here, and then Bob somewhere here, and then Bob somewhere here. And the other way could be, you know, Bob starts, Bob, and in between Alice starts, and then Alice ends, whatever. But the thing is, one of them will come first, right? Whoever. And whoever comes first, if they leave before the other person comes, so yeah, but then the thing is, the intersection point will be the person that comes first. He will also leave, right? Focus on one person. Focus on Alice. She came and she left. So now Bob, if it have to intersect with her here, 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 anywhere, if Bob start, if Bob end is less than Alice start, then it can't. If Bob start is greater than Alice end, then he can't. Otherwise there will be an intersection, and that intersection you'll figure out. Let's do typical. Somebody comes and then this, right? it will be the minimum of the two endpoints, the minimum of the two ends and the maximum of the two starts. Does that work always? Minimum of the two endpoints and maximum of the two starts? Even if they didn't meet, so the minimum of the two is this, or the maximum, sorry. Okay, the maximum is here and the minimum of the two ends is here. Okay, so you do maximum, minimum of end minus maximum of start. Okay, so 1 to 2 and 3 to 4. So you're saying is minimum of the and, so 2 and 4 minimum is 2, so 2 minus maximum of the start is 3 and 4. Okay, minimum. Okay, so you don't need all of this. Okay, now I will argue some things here, which is the inclusive dates. Okay, which is that 1 2 and then 2 to 3. If that happens, then both of them are there on 2, right? Yeah, both of them are there on 2, so you would do what? Okay, so the maximum of the ends, minimum of the ends is 2. Okay, so 2 plus 1 now. Yeah, you can do plus 1, that's okay. So you think this is the final answer? So now if common is less than 0, return 0, else you return common. Now first let's try and convert a string into a day number. So you'll get in which aspect you get this month and this year. Yeah, so let's solve this as well once and for all. Okay, ये भी कर दिया. Now what I'm gonna do is very simple. I'll divide it into two by a hyphen. So split it based on this, and then you do so the month number has to be from 0 to 11, and you will get 0, 12 and whatnot. So you'll make it what, -1 exactly. Okay, and this is fine. So you would return whatever your month is. If it's the first month, for example, or is 0, okay, let's run. Perfecto, works beautifully, no? Let's say if it passes. It does. Great. Alright, what is the problem number? This was problem number 6. Let's do problem number 7. Okay, problem number 7. You are given an integer nums and an integer k. In one operation, you can choose any index I where I is less than, okay, whatever, and change nums of I to nums of I plus x, where x is an integer from the range -k to k. You can apply this operation at most once for each index I. The score of nums is the difference between the maximum and minimum elements in nums. Return the minimum score of nums after applying the mentioned operation at most once for each index in it. What the hell, man? Who does this nonsense? Okay. So nums of 1 equals to 1. We are given a single array with a single entry whose value is 1 and k equals to 0. Okay, what does k mean? K gives you a range. So your range is -0 to 0. You have to apply at most once. You can also apply 0 times. Then you can choose any index I. Okay, we only have a single index, and change this to +0. Nothing, you can do anything. I mean, it is 1 minimum maximum. It is bullshit. Let's look at the second example. 0 to 10, k equals to 2. Right now the difference is 10. I have to minimize that difference. So what I'm doing is I'm converting this to +2. Yeah, and I'm converting this to -2, and so making it 8. So 8 minus 2 is 6. Getting some sense of it now. So here what you want is return the minimum score of some sort of applying the mentioned operation at most once. But you have to only, I mean, you have to find the maximum and minimum element first of all, right? You do find the maximum and minimum element. The minimum element you increase, the maximum element you decrease. Okay, so first find the minimum and maximum element. Let's do that. Okay, so So now I have the min and the max element. If it's an empty array, can it be an empty array? No, it can't. Okay, so now if max dot min is, so basically 2 times k is, your range is 0 to 2k. Your range actually is, yeah, exactly 0 to 2k. Whatever your difference is, you can reduce the difference by 2 times k. So this is what I would say. If the difference is less than equal to 2 times k, then you can return 0. You can make the difference 0. Else you can return diff minus 2 times k. Simple as that, right? Okay, let's run. I hope it works. If it works, it's great. Oh, it does, at least for these two cases. Submit. Beautifully done, fantastically done. Okay, problem number 7. Everybody understood? Nobody's listening? Happy computing, bro. Thank you, bro. Smallest number with all set bits. This is our problem number 8. We'll do only 10 today. Hopefully we can do. You're given a positive number n, return the smallest x greater than or equal to n such that the binary representation of x only contains set bits. I would find number greater than n, okay, which only contains set bits. That means all bits are set. That is only possible if you are a power of 2 minus 1. So isn't this n interesting? Basically what I need to do here is I need to find the rightmost the most significant one, make all other yeah, I can do whatever. For 5, yeah, what operation that I should I do on this number? I have to find the most significant one. To find that mask of most significant one, I can go through all the bits, find the most significant one, and then OR it with a number which has all ones set or something like that. What about 0? Well, the answer is 1 then. So if n equals 0, return 1. Sure. Let's do this. So now I have the last one index. I could just create the result also here itself, no? Yeah, it's okay. I mean, so let's try to get the result here itself, I would say. Okay, can I do this then? Can I do this? And can I do all of this? And can I do return and something like that? I'm not very sure about it, but let's see. Alright, it works. This is what problem number 8. Submit. Doesn't beat a lot of the ones, but that's okay, I guess. Submit. Okay, problem number 9. Compute, calculate delayed arrival time. What is delayed arrival time? If you are given a positive integer arrival time, denoting the arrival time of train in hours, and another positive integer delayed time, denoting the amount of delay in hours, return the time when the train will arrive at the station. Okay, arrival time, delayed time. Arrival time is 15, delayed time is 5. Arrival time of the train was at 15:00. It's delayed by 5 hours, so now it will arrive at 20 hours. Okay, are you asking me to just do the addition here or what? This is problem number 9, yes? Yeah, this is fine. this is a 13 plus 11 is 24, which is 0 0. Are you asking me to just add two numbers, brother, and then do a mod by 24 or something? Are you asking me to return arrival time plus delay time percentile 24? Is that what you're asking me to do, really? Okay, if that's what you want, I'll do that. Let's do the last problem and be done with it. And the last problem is quite big. We have a recent counter class which counts the number of recent requests within a certain time frame. Implement the recent counter class. Recent counter counts the number of recent requests within a certain time frame. Okay. Implement the recent counter class. Recent counter class initializes the counter with the recent requests. 0 recent requests. Okay. Ping. That's a new request at time t, where it represents some time in milliseconds and returns the number of requests that has happened in the past 300 seconds, 3000 milliseconds. Specifically return the number of requests that have happened in inclusive range t minus. Okay, so you are adding a request, you're telling that at this time t there is a request, and then you return the number of requests that happened in last 3 seconds. Okay, that's ping. What else is there? It's guaranteed that every call to ping is a strictly larger value of t than the previous. Okay, let's look at this example. Recent counter was initialized due to ping 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 ping. First you return 1, for the second time you return this, for the third time 3001 you return 3, 3002 3002 minus 3000. Okay, whatever. You have to maintain an array. Yes, you have to maintain an array. Of what size? Array of size 3000. Let's say you maintain an array of size 3000. No, you don't maintain an array of size 3000. Well, you do. The return is a problem, right? Otherwise there is no such problem. Okay, let's understand 3000 to 1 again. So at t equals to 1, no problem. At t equals to 100, no problem. Till t equals to 3000. So in the last 3000 milliseconds, so it says exclusively, it says t minus 3000 to 3000. So 3001 minus 3000 is 1. So once a 3001 is what I'm interested in. So when I get a request at t equals to 3002, I'm only be interested from 2 to 3002. Any other request that came before that, I wouldn't even care about it, which is also fine. A sorted array where you do a binary search and remove these elements, or what? What sort of data structure would you use? The question is, what sort of data structure would you use to represent this data, where you are only interested in any events that happened in last 3000 seconds, and then events can be sporadic. Starting, okay, an array of size 3000, what about that? Okay, an array of size 3000, well, not even an array, well, an array of size 3000 works well for me, but every time you get a value, you will have to do a lot of readjusting, lot of array shifting. I don't want to do that. Okay, so you don't want to do array shifting. What about then key value pairs? Okay, so you're sorted based on the key. You have a key and a value. The question that I'm asking is, how many entries are there? How many keys are there in the array between this and this? Has to be a sorted sort of a thing, so you have to maintain like a sorted tree set or something. Have to maintain a sorted tree set. And then the question is, can there be multiple entries? Strictly larger value of t than previous call, it says here. So use a tree set. Okay, so you're saying this class will contain a tree set of size what? No size, okay. But the fact is there is a recent counter, so you would like a what? What do you want? Like I should have a priority queue of size this, and then I should be able to query a priority queue. Remove the elements which are less than this. Start with the tree set. Now you want to find the number of elements in the set which I range this to this. Now I'm going to have to look at Java docs here. Java docs tree set. There's no such thing as find. There is a get. Okay, method add ceiling returns the least element in the set greater than or equal to the given element. Number of elements can I find? Ceiling and floor you can get. Okay, is it this a subset? Whose elements range from inclusive to 2 element exclusive. That is also fine for us, because and then you get a size of it or what? Okay, let's try the subset thing and we'll use this. Both are inclusive, right? So return set dot subset of t minus 3000 true t true dot size. I do not like it at all, but it's something. It doesn't even work. What was the problem there, bro? Why is not compiling? Spelling mistake? Okay, submit. It does work, doesn't beat anybody. I think it's not a good use because this will keep on growing. Memory complexity is something I don't like. Okay, let's look at the editorial. It is not there. Let's look at some other solutions. Okay, let's understand what they are using. The goal of the recent counter class is to count the number of requests that occurred. ये सब मुझे समझ में आ गया. The data structure use an array records to store the timestamps of requests. Then start and end indicates indices mark the window of valid request within this. Okay. Ping t at timestamp. Insert the current timestamp at the position indicated by end. Remove outdated requests. Increment the start index until there are requests like you use like what you call a circular array and maintain a start index until the requests are within a 3000 millisecond range. Do this fill request, then the count of requests within the range. If it's using a circular array, then I understand that's what it is doing. Start equals 0 and equals to 0. Takes slightly bigger, I don't know why, but okay. It's using OFN, and there also it was doing like a binary search. I'm not seeing any percentile being done. That's my problem. That's exactly right. I would like that. I would like that. This is better. I like this approach. Just use a simple queue. Yeah. Use a queue, and then you in the queue while the elements in the pop are bad, just remove them and then return the queue. Yeah, I would use this. Let's do this. So yeah, you get rid of it, get rid of that, confirm. Description. Let's try it again. So you maintain a queue. So you do what? You do first queue add. What is a queue constructor? What are the right terms? Add and remove, yeah. So you add t in the queue, and now you remove, right? So how do you remove elements from the queue? So you need a iterator for the queue. In Java, how do you iterate over a queue? Yeah, you get an iterator. Okay, so I'm finding it fucking difficult to. I mean, if it was something that I had considered, it would have been a little bit easier. Ultimately, I would want to remove something, and I will do q return q dot size. That's fair. I guess I'll make it even more simpler. Just remove it. Yeah, that's it. Submit. Right, this is better. All right, good here. Can stop.